Hello class, in this video I'll be showing you how to use coterminal angles to find the 6 trigonometric values of any angle that's less than 0 degrees or greater than 360 degrees. Let's begin. Two angles in standard position are said to be coterminal if they have the same terminal side. So before I get to all the explanations on the right, I'm going to draw a diagram. So in this diagram, I'm going to place theta like such. Theta is in standard position because the vertex is at the origin and the initial side is along the positive x-axis. And here is the terminal side. I'm going to draw two more angles. So in this diagram, theta sub 1, and theta sub 2 are all coterminal because they are all in standard position and they share a terminal side. So over here to the right, if theta is in degrees, theta plus 360 times k, where k is an integer, is an angle coterminal to theta. If theta is in radians, then theta plus 2 pi k, where k is an integer, is an angle coterminal to theta. And what is so special about coterminal angles? Well, since coterminal angles share a terminal side, it follows that the value of the trig functions of coterminal angles are equal. So why is that the case? Well, notice that the terminal side passes through the point A comma B, and all of the angles' terminal sides pass through that point. Also notice that all three angles share the same radius. Well, if the terminal sides all pass through the same point and the radiuses are all equal, it follows that the value of the trig functions of coterminal angles are equal. And how is that going to help us? Well, let's see. I have a few examples. It says, use a coterminal angle to find the exact value of each expression. So the first expression is the cosine of 390 degrees. So the first thing you're going to want to do is you're going to want to write 390 degrees as some angle plus 360 times some value of k. So in this case, it looks like we can place a 30 here and a 1 right there. So k is equal to 1. Because 30 plus 360 times 1 equals 390. So that means 390 and 30 are coterminal. So the cosine of 390 degrees is equal to the cosine of 30 degrees, which is equal to the square root of 3 divided by 2. Next, tangent of 25 pi divided by 4. Now we're dealing in radians, and we want to find an angle, theta, that when we add it to 2 pi k, which is right here, we're going to get 25 pi fourths. So we want to find, first, another way of writing 2 pi using the fraction with a 4 in the denominator. And in that case, I believe it's going to be 8 pi. So what this implies is that 25 pi fourths can be written as some angle plus 8 pi fourths times some value of k. And if we think hard enough, 8 times 3 is 24, and then 24 plus 1 will give you 25. So pi plus 8 pi fourths times 3 will give you 25 pi fourths. So in this case, 25 pi fourths and pi fourths are coterminal. So the tangent of 25 pi fourths is equal to the tangent of pi fourths, which is equal to 1. Example 5. The cosecant of negative 90 degrees. So we're going to start by writing negative 90 degrees is equal to something plus 360 times some integer k. And since our angle is negative, I'm going to make k a negative. And what negative number are we going to make it? Well, if I write negative 1 here, and then write 270 right there, it should follow that negative 90 is equal to 270 minus 360. And the two coterminal angles are negative 90 and 270. So the cosecant of negative 90 degrees is equal to the cosecant of 270 degrees. And that is one of the special angles I talked about in a previous video. So let's go find it. So if you look at the bottom row of this chart, cosecant of 270 degrees is negative 1. So the cosecant of negative 90 is negative 1. And for the last one, negative 5 pi thirds. Well, just like example number 4, we're dealing with a fraction. So 2 pi happens to equal 6 pi divided by 3. So we want to write negative 5 pi thirds as something plus 6 pi thirds times an integer k. And since your angle is negative, I'm going to try k is equal to negative 1 first. And I believe pi thirds minus 6 pi thirds will give you the desired negative 5 pi thirds. So the two coterminal angles in this case are negative 5 pi thirds and pi thirds. So the secant of negative 5 pi thirds is equal to the secant of pi thirds, which is the reciprocal of cosine. And the cosine of pi thirds is a half. So this solution is 2.